Wipe those stress lines from your brow and perk up your eyes, ears and mind for all the custom-made advice and exam counseling that we have in store for you. Hi, I'm Arjun Bhagat and today we'll trace trends, practice questions and in the process, study smart.
Today we're discussing a very important chapter from your syllabus, Integrals, which is from the unit Calculus. This is not a unit to be taken lightly as it accounts for a massive 44 marks in the board exams. Before we study the past year's trends for integrals, you should know that the CBSE marking scheme has changed since 2008. Under the new marking scheme system, the CBSE asks 3 types of questions. 1 mark or very small answer type questions and 4 mark or short answer type questions. Although you can expect a few surprises, we can safely assume that 1 6 marks or long answer type question will be based on this chapter.
As you know now that integrals is a very important topic under the umbrella of calculus. So if you've ever felt intimidated by this topic or feel that it may not be your strongest point, then you've tuned into the right show, because coming up next we have a quick recap of the important topics from this chapter.
Revision of integrals is not complete without the following. Basic formulae of indefinite integral. Indefinite integral by substitution method. Indefinite integrals using trigonometric identities. Some important formulae of indefinite integrals. Indefinite integral by parts. Indefinite integrals by partial fractions. Basic concept of definite integrals. Definite integrals as limit of a sum. Properties of definite integrals.
Those were the key revision points, but I'm sure you're all wondering about the capabilities which this chapter will test you on. So let's go to Knowledge Tip.
When it comes to the abilities on which students will be tested, we have found that most questions are based on either conceptual or knowledge ability.
So bring in your pens and papers to learn how to solve today's model question. That question which typifies the kind of problems you can expect in the examination.
This is a conceptual ability 6-mark question that appeared in the 2008 examination and uses both the formula of integration and properties of definite integral. It will test your comprehension as well as application of both. Solve the problem of definite integral of a given function x, tan x upon sec x plus tan x within limits 0 to pi. Let's begin by naming the desired integral I and designate it as an equation number 1. Now by using the property and simplifying it, we get I is equal to pi minus x tan x upon sec x plus tan x. Let's call this equation number 2. So on adding both the equations, we get 2I is equal to pi into integral of sine x by 1 plus sine x into dx. Next we add and subtract 1 to the numerator. Finally, using the conjugate of the denominator, we get pi square minus pi into indefinite integral of sec square x minus sec x into tan x into dx at the limits from 0 to pi. There is just one important step left now. By integrating, we get 2I is equal to pi square minus 2 pi. The final answer we get is I is equal to pi square minus 2 pi by 2. And that awards you the entire 6 marks.
I hope you noted down each step of that model question solution. Remember how hard you practiced for that important cricket or football match, or how long you rehearsed for that music performance in your school's annual function. Well then, you should be quite prepared to take on our practice session coming up next. After all, practice makes perfect.
Definite integral of log 2 minus x by 2 plus x at the limits from -1 to 1. This question is based on conceptual ability as it tests your concept of integration of logarithmic functions under given limits. Let fx is equal to log 2 minus x by 2 plus x. Now, on putting minus x in place of x, we get minus log 2 minus x by 2 plus x, which is equal to minus fx. Since the function is an odd function, the integration of fx from -1 to 1 is equal to 0. Integral minus a to a fx dx is equal to 0 if f is an odd function.
I hope you've now understood how to make that difficult question into an easy one. Next, let's solve a problem that you may face in your exams.
This is also a 1-mark question from the 2008 paper and is considered important for the upcoming examination. This conceptual ability question tests substitution as a method of integration. Here we have to solve the integral of the function x square by 1 plus x cube. As mentioned, this problem requires the use of substitution method, and usually we make a substitution for a function whose derivative also occurs in the integrand. So put 1 plus x cube is equal to t. This implies that 3x square dx is equal to dt. Now the given integration I is equal to 1 by 3 into the integration of 1 upon t, which is equal to 1 by 3 into log t plus k. Please note that here k is the constant of integration. So we find the solution of this problem is equal to 1 by 3 log mod 1 plus x cube plus k. You have earned a very important mark for your efforts.
The two questions we've solved until now have been 1-markers, but that doesn't mean that you can afford to take them lightly. Remember, when it comes to the board exam, every step, every mark can make a huge difference. Ready to forge ahead? Let's go.
Our third practice question involves your understanding of the modulus function as well as definite integration. This conceptual ability question is for 4 marks and is considered difficult. We have to find the result of the integral of mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3 with respect to x, given the limits from 1 to 4. Begin by stating the definition of modulus functions. The definition of modulus splits the functions to give us integral of x minus 1 from 1 to 4 minus integral of x minus 2 from 1 to 2 plus integral of x minus 2 from 2 to 4 minus integral of x minus 3 from 1 to 3 plus integral of x minus 3 from 3 to 4. This fetches you another 2 marks. Solve this integration and put the limits in place of x to get your final answer, which is 19 by 2. Award yourself full marks for completing this answer.
All the questions that you just solved involve a thorough conceptual understanding of integrals, and if you don't get those basics right, you won't be able to recognize which concept applies to which question. So no matter how many times you need to ask your teacher for those clarifications, please don't hesitate. Meanwhile, Topper is always there to help you. It's time for a short break, after which we'll practice some more questions and reveal the hot question for the day. And you won't want to miss our tips segment for all those useful pointers. So now I'm going to leave you with this breaking question.
Solve the following expression by integrating the function x into 3 to the power x. We'll be right back with the solution, so don't go anywhere. Before the break, we had asked you to integrate the function x into 3 to the power x. Here the solution is: let x be the first function and 3 to the power x be the second function. Use aieee principle in choosing first and second function. On solving this using integration by parts, we get the result x into 3 to the power x by log 3 minus 1 upon whole square of log 3 into 3 to the power x plus c, where c is the constant of integration.
Welcome back. I hope the topper in you was able to solve that problem with no difficulty, especially after our discussion in the previous segment where we talked about past year trends and solved not just the model question but also 3 practice questions based on definite integrals, substitution and the function of modules. I'm guessing you're feeling very confident now in these topics and are ready to take on more challenges. So let's now solve some more practice questions.
Like the question asked in the previous segment, this one is also based on substitution as a method for integration and test your conceptual ability. You need to find the value of the definite integral of sine x plus cos x upon 9 plus 16 sine 2x at the limits from 0 to pi by 4. When solving this substitution problem, the most important thing to keep in mind is to change the limits according to the substitution. If you omit this step, the entire answer will be marked wrong before you even begun. So let the given integral be the following. On substituting for sine 2x and adding or subtracting 1, we get I is equal to the integral of sine x plus cos x upon 9 plus 16 into 1 minus whole square of sine x minus cos x on the same limits. Put sine x minus cos x is equal to t, which implies that cos x plus sine x dx is equal to dt. At x equals to pi by 4, t is equal to 0. And at x equals 0, t equal to minus 1. Now, I is equal to the definite integral of 1 by 9 plus 16 into 1 minus t square at the limits from minus 1 to 0. This simplifies to 1 upon 5 square minus 4t whole square. The denominator is of the form a square minus x square, so we use the corresponding special integral. On solving and putting the limits of t, we get the result 1 by 10 into log 9.
Now let's move on to another question that deals with definite integrals as the limit of sum. There's a chance that you might find this topic slightly tricky. If so, then watch and learn.
Definite integrals as limit of sum is the primary rule to finding the value of a definite integral of any function. Now, while this is a very interesting concept, it can also be challenging and intimidating for some students. In this conceptual ability question, we are required to understand the behavior and recognize patterns of the series. So let's start by stating that a is equal to 0, b is equal to 2 and fx is equal to x square plus 2 x plus 1. Then h is equal to 2 minus 0 by n. So it follows that nh is equal to 2. Now by the definition of limit of a sum, we put the value of a, b, h and fx in the formula of limit of a sum. Now f of a is equal to f of 0 is equal to 1. F of a plus h is equal to f of 0 plus h is equal to h square plus 2h plus 1. F of a plus 2h is equal to f of 0 plus 2h is equal to 2h whole square plus 2 times 2h plus 1. Moving on the same lines, we get f of a plus n minus 1h is equal to f of 0 plus n minus 1h is equal to n minus 1 whole square h square plus 2 times n minus 1h plus 1. This gives us, on substituting in the formula of limit of a sum, limit h tends to 0, h into n plus h square into sum of squares of first n minus 1 natural numbers plus 2h into sum of first n minus 1 natural numbers. And on substituting required formulas and value of nh equal to 2, the function reduces to limit h tends to 0, 2 plus 2 into 2 minus h into 4 minus h by 6 plus 2 into 2 minus h, which on solving gives us 26 by 3.
We are nearing the end of our practice session, and if you're still charged up, then well done. After all, when a challenge is confronted head-on, it can be very energizing. So let's go into our final challenge.
You'll need both knowledge and conceptual ability to solve this problem. This means that you need to do some initial planning and strategizing as you connect previously learnt knowledge with recently acquired concepts of definite integration. Here we have to find the definite integral of mode of sine x at the limits from minus pi by 4 to pi by 4. We know that sine x is equal to 0 at x is equal to 0. So simply apply the definition of mode of x to mode of sine x. Now, write that the function is defined as sine x in the interval 0 to pi by 4 and minus sine x from minus pi by 4 to 0. Is the solution beginning to appear familiar and simple now? Then just integrate it by putting limits and simplifying. You should have the answer as 2 minus root 2.
Just like a gardener puts in fertilizers, insecticides and a lot of hard work to watch a seed grow into a tree, you also need to apply a lot of conceptual ability as well as hard work, which will surely see you transform your exam performance into success. So keep practicing hard and keep solving newer and more challenging questions. Speaking of which, it's time for today's HOTS question. For those of you who are not too familiar with it, HOTS stands for High Order Thinking Skill, which is what the CBSE expects you to hone for answering its new type of question. Take a look.
Here is a 6 marks problem which may also appear as a 4 marker in a simpler form. To solve this, we have to use substitution in conjunction with limits to find the definite integral of log u by square root of 1 minus u squared at the limits from 0 to 1. So first we write that u is equal to sine x, which implies that cos x dx is equal to du. Also, the limit needs to be changed according to the substituted function. At u is equal to 0, x is equal to 0, and at u is equal to 1, x is equal to pi by 2. Now I is equal to the definite integral of log sine x dx at the limits from 0 to pi by 2. This is equation number 2. Now, we use the property of definite integral limit 0 to an integral of fx dx is equal to 0 to an integral of f of a minus x dx, and get the definite integration of log cos x at the limits from 0 to pi by 2. This is an equation number 3. Next, add equations 2 and 3 to get 2I is equal to definite integral of log sine 2x minus log 2 at the limits from 0 to pi by 2. Now, let's definite integral of log sine 2x at the limits from 0 to pi by 2 is equal to I1. Here use the substitution method once again and put 2x is equal to t, implying that 2 into dx is equal to dt. Please note that the limits will be changed from pi by 2 to pi. Now using the fifth property of definite integrals, we get I1 is equal to definite integral of log sine x at the limits from 0 to pi by 2, which is equal to I. This is equation number 5. Using equations 4 and 5, we get I is equal to minus pi by 2 into log 2. This is the last step and the final answer.
With that, we end our volley of questions, be it model, practice, or simply hot. Of course, if you have any doubts or want to go over any of these questions that we covered today, you can always log on to our website www.topperlearning.com, where we have exhaustive revision lists, sample questions, and guidelines for you. Well, I think you deserve a special treat as a reward for coming this far, and that is why we've devised a very special list of do's and don'ts that you can be very careful about in the exams. Check out today's exam tips.
Most formulae of integration can be derived, but that will cost you precious minutes of the exam. So don't take a chance and have all the formulae of integration on your tips. Be careful when performing substitution. When we put a function of another variable in place of a variable or function, then we must remember to change the variable of integration. And if substitution is required in a problem of definite integrals, then remember to change the upper and lower limits of integration according to the new variable. Do not forget to write k as the constant of integration, as there are marks for it. Usually when integrating by parts, if any function is a power of x or a polynomial in x, then we take it as the first function. However, in cases where the other function is an inverse trigonometric or logarithmic function, then we take that as the first function. So remember the aieee rule and use it in such situations.
It's time to bring the curtains down on today's exam special on integrals. I leave it to you to integrate all that you've learned to get the best results. Just remember that a combination of hard work, revision, and conceptual clarity is a foolproof method of going straight to the top. So be a topper and study smart. Take care and goodbye.